Welcome back, Math Masters. A new scroll has arrived at the dojo gates. Today, you'll begin training to earn the Evaluating Expressions badge. 6 times 2 plus 4 minus 10. Is this an expression or an equation? Explain how you know. Write a basic numerical expression that matches this situation. A student starts with 12 points. They earn 5 more, lose 3, and then gain 4. Evaluate your expression by performing the operations from left to right. What is the result? Study well. The path to mastery begins now.
Welcome back, Math Masters. Today, we're looking at expressions. But what is an expression? Based on the number sentence in the challenge, I have a feeling we'll need our knowledge of mixed operations to conquer today's challenge. Have your guided notes ready. Training starts now. To begin our investigation, take a look at these two number sentences. One is an equation and one is an expression. They seem really similar to each other, but they're not exactly the same. Can you tell the difference? When comparing the two number sentences, we have the same digits to start: 6, 2, and 1. We also have the same operations: multiplication and addition. What's different between the two? Exactly. The second number sentence includes the equal sign and the solution. These are excellent observations, but which one is the equation and which one is the expression? The first number sentence is known as an expression. Expressions are mathematical sentences made up of numbers, symbols, and operators. Think about an expression as a recipe. It has all of the ingredients we need to make the dish, which in this case are the numbers. And a recipe also includes the directions to make the dish, which is represented by the operators. We're told what to do to make the meal, but we haven't done it yet, so we don't know the result. The second number sentence is known as an equation. Equations are mathematical sentences that show that two expressions are equal to each other. They contain expressions, but instead of just informing us of the ingredients and directions, an equation also shows us the finished dish, which is represented by the solution. Hey, Mia! That's an excellent training tip to help us remember the difference between an equation and an expression. When we study the words, we may notice that the word equation contains the same beginning sounds as the word equal. This can help us remember that only equations have an equal sign and expressions do not. But why do we need to know the difference? Equations are made up of two expressions. Expressions can be evaluated by performing the operations, but only equations have a solution. The solution may be provided, or you may need to take some steps to calculate it. Now that we know the difference, let's focus on interpreting a scenario to make an expression. Consider this problem. Mia's mom packed lunch for her and her friends to eat during a tournament. She brought 3 plates with 4 sandwiches on each plate. Mia and her friends eat 6 sandwiches during lunch. Then Mia's mom makes 3 more sandwiches. How can this be represented by an expression? When working with real-world scenarios like this, we'll begin by marking the important numbers in the problem. Circle, highlight, or mark them so our numbers stand out. 3, 4, 6, and 3. Then we're going to visualize the scenario. Try to come up with a picture inside your mind as we read through the problem again. Mia's mom packed lunch for her and her friends to eat during a tournament. She brought 3 plates with 4 sandwiches on each plate. Imagine 3 round plates, each containing 4 sandwiches. Mia and her friends eat 6 sandwiches during lunch. Since the sandwiches have been eaten, we don't have them anymore. Cross out 6 of the sandwiches. Then, Mia's mom makes 3 more sandwiches. These are new sandwiches that are not part of the original set, so we can imagine 3 more. Now that we've created this visual of our problem, how can we interpret it to write an expression using numbers and operators? Pause here to try this on your own. Use the problem and the visual to help you. What did you come up with? If we start with the plates and sandwiches, there are 3 plates and each plate has 4 sandwiches. We could use repeated addition to add up how many sandwiches Mia's mom brought to the tournament. This would look like 4 plus 4 plus 4. To simplify this, we know that repeated addition is the same as multiplication, so this can also be represented as 4 times 3. Next, Mia and her friends eat 6 of the sandwiches. Those sandwiches are now gone, and we can subtract 6 from the number of sandwiches we started with. Finally, Mia's mom makes 3 more sandwiches. These are new sandwiches and should be added to the total. Our final expression for this scenario is 4 times 3 minus 6 plus 3. Great work! Let's try one more example involving expressions. This time, we are going to write the expression and then we'll evaluate it. To evaluate an expression is to find the numerical value of the expression by performing the required operations. We will do this by working through the operations from left to right. In Mia's last match of the tournament, she scored 5 points in each of the first 3 rounds. Then, she earned 7 more points in the last round, but lost 3 points for a penalty. How many total points did she earn? Put your learning to the test and try this one on your own. Pause here to visualize the scenario, create an expression, and then evaluate the expression by working through each operation from left to right to figure out Mia's total points. So, how many points did Mia earn in her last match? Mia scored 5 points over 3 rounds. This can be represented by 5 times 3. Then, she earned 7 more points in the last round. Those points should be added onto the total. But then she loses 3 points for a penalty. So we need to subtract those 3 points away at the end. Evaluate from left to right to find the total. 5 times 3 is 15. Remember to always bring down the rest of the unsolved pieces in the order they appear in the expression. Add 7 more and we get 22. Don't forget to bring down the minus 3. Then subtract the 3 points for the penalty and Mia is left with 19 points. Great work! Your challenge still awaits. Complete it and the Evaluating Expressions badge is yours. 6 times 2 plus 4 minus 10. Is this an expression or an equation? Explain how you know. Write a basic numerical expression that matches this situation. A student starts with 12 points. They earn 5 more, lose 3, and then gain 4. Evaluate your expression by performing the operations from left to right. What is the result? Pause here to complete the challenge in your guided notes. Use everything you've learned today to show your mastery. When we look at this combination of numbers and operators, we can tell this is an expression because it does not contain an equal sign or a solution. In the situation provided to us, the student begins with 12 points. Then we add the 5 points they earn, subtract the 3 they lose, and add the final 4 points they gain. The result is the expression 12 plus 5 minus 3 plus 4. Evaluate this expression from left to right. 12 plus 5 is 17. Bring down the rest. Subtract 3 from 17, and we have 14. Bring down the plus 4. Add the final 4 points to get a total of 18 points. So, what have we learned today? We learned that expressions are made up of numbers, symbols, and operators. Equations are made up of expressions and contain an equal sign. We visualized problems to interpret them into expressions, and then we evaluated these expressions from left to right. You've earned the Evaluating Expressions badge, but your training isn't over just yet. Be sure to complete the practice questions and extension activities that go with this lesson to practice interpreting and evaluating expressions. And remember, Math Masters, in math, as in training, progress comes with patience and practice. I'll see you next time. Hey!